So now that we have the first derivative of the parametric curve here, a nice logical next step might be, can we find the second derivative? And we're going to find that it's not quite so nice. It's definitely possible, but this thing might kind of explode a little bit. So remember, we're going to find the second derivative of y with respect to x, d squared y dx squared, and that is going to be taking the derivative, as we saw earlier, the derivative with respect to t of dy dx divided by dx dt. Now the good news is we already have dx dt. dx dt is this thing right here. So the denominator of this fraction is 2 plus, I'm going to put the pi in front. I just like the way that looks better. 2 plus pi times the cosine of pi t. All right, swell. All right, so now all we have to do is take the derivative with respect to t of dy dx. Well, that's this whole fraction. So you guessed it. We've got the quotient rule. So we can do it. It's not impossible. It just gets a little tedious. So the quotient rule gives us this fraction where it's u prime v minus u v prime all over v squared, right? So top, we're going to take the derivative of the top. So that'll give us a negative pi, which we already started off with, but also another pi that we're going to get from the chain rule, times the cosine of pi t. That's u prime. And then v is 2 plus cosine pi t times pi. All right, well, great. That's u prime v. Now we're going to do minus uv prime. Well, u is negative, so we'll do a double negative, makes it positive. Pi times the sine of pi t. And then we're going to multiply that was u, we're going to multiply that by v prime. V prime being the derivative of the denominator, so we've got, well, the 2 goes away. That's one of the only nice things about this problem. And then we're going to take the derivative of the cosine, that's going to be negative sine. We're going to have that negative pi squared again, so negative pi squared times the sine of pi t. All right, that is the numerator of the answer. The denominator is v squared, right? So we're going to do 2 plus cosine of pi t, and we'll square that whole thing. All right, well, notice that we're dividing by the same thing 3 times, right? Twice here, and then one more time here. So perhaps we can save ourselves a little bit of a headache. And we'll change this. Let's make this a little bit more readable. And just change this to a 3. We've got 3 factors of that. Now there's the answer. We might be able to simplify this a bit. Perhaps we could factor out some stuff in the numerator. I'm not seeing a whole lot, though. I see a pi squared. Yeah, we can factor out maybe a negative pi squared. Other than that, I don't really see much else we can do. I think I missed a closed parentheses here. Yeah, let's close that parentheses right there. That was a problem. You can see how these are very complicated answers and very hard to work with. I'm just looking at it real quick to see if there's anything else we could possibly do. Well, if we factor out a negative pi squared, that might be worthwhile. I see something that may help things simplify a bit. So if we factor out the negative pi squared, then that's gone here. We've got 2 times cosine of pi t. 2 times the cosine of pi t. And then we also have pi times the cosine of pi t times the cosine of pi t. So that's going to be plus pi times the cosine squared of pi t. And then, let's see, this negative pi squared is gone, but everything else is still there, so that's pi times sine of pi t times another sine of pi t. So that's going to be plus pi times the sine squared of pi t. All right, so sometimes simplifying things out doesn't take you too far, but I see at least one more thing that we can do that maybe will make this a little bit less of a behemoth of an answer. And I'm guessing you guys see it at this point too, because it's your favorite trig identity, isn't it? That plus that is 1. So if we were to take just these two terms, the pi times the cosine squared of pi t plus pi times the sine squared of pi t, factor out the pi, what's left is just 1. So in fact, we just have plus pi inside there. So that is, not the most amazing thing in the world by any stretch of the imagination, but at the very least, our final answer can be written like that. Wow. And again, this is a good expression to use when you're interested in the concavity of the curve and you know the t value in question.